Today we will be doing problem 52. So we have this, so these the x, y, and z axes. Crudely sketching it, we have this vector here, r arrow, which is 2I plus j plus 3k. First, we compute the magnitudes of the x, y, and z components. Their magnitudes are obvious. They're the absolute values of the coefficients, which, because all the coefficients are positive, are just the coefficients. So the x magnitude is 2, the y magnitude is 1, and the z magnitude is 3. Now we compute the magnitude of the vector itself. This is the square root of the sum of the squares of its coefficients, of course. And now we compute the angles between the axes. These are known as direction angles. Now, notice something interesting here. They form a triangle where we'll call them theta, phi, and gamma. Where by intersecting the diagram, these numbers look familiar. They're the x, y, and z magnitudes. So we say the cosine theta is equal to 2 root 13 over 13. Cosine phi is equal to root 13 over 13. And the cosine gamma is equal to 3 root 13 over 13. Where is a... Here's a calculator. Excuse me for a second while I... So, note to self, plan your... So we see that the first angle is about 0.98 rads. The second angle about 1.29 rads. And the third angle about 0.59 rads. Where? Okay, with this said, now you'll notice something. That magnitude multiplied by a unit vector in that direction, and by the cosine of that angle, forms the component of the vector that is in that direction. In other words, a projection. So a projection will be useful in physics, because suppose we have a force exerted along whatever direction. And if we want to know how much stress or acceleration or tension, or whatever we want to measure, is on object in whatever other direction, we can then do a projection of object 1 onto object at 2. Now what? Well, the projection formula for vectors u and v, projecting from u onto v, this is a vector. It is derived from that where theta is the angle between them. Is there an absolute value here? No, there is not. Now, of course, to get the magnitude of the projection, because it's the magnitude of u multiplied by this, and because it's in v's direction, we have to multiply this by unit vectors. In the direction of v, and hence we get this. Remove the absolute values again. That's it.